Hello everyone, this is Pranav and Vishal, and this is our assignment 2 for the course of Introduction of Robotics. And we are with a tooling robot, and this time we have attached the end effector, that is a pen, the complete system. So this is the overall setup. We have two servos, servo 1 and servo 2. These are the aluminum bars that is connected, and then we have a micro stepper actuator, that's a linear actuator, and this is like the linear bearing which restricts the motion of the pen. And then we have it hooked up with Arduino. So as described earlier in the documentation part, since there was a bit of a problem while interfacing MATLAB and stepper motors, so we have connected two different UNOs. One takes care of the stepper, and the first one basically uses digital pin to control the steppers, because we just have up and down movement for the steppers. And this is the complete setup. We have a motor shield stacked up on Arduino Uno, and this is like the Arduino that is connected to the MATLAB, and these are all connected to the motors, except the servo motors take power from this board but signal from this board. Now let's look at the GUI. So let's just take a look at the GUI. So I'll just run the GUI to make sure we can view all the components. So here we have the end effector positions. These are the new buttons that we have added. One of the button is keyboard input, and that was programmatically created. So that means whenever the plot is called, you have some internal MATLAB properties that basically blankets all the custom callbacks. So we have just made the button appear programmatically after the plot is loaded, so basically it doesn't let it overshadow. So let's just initialize the Arduino. First of all, we'll just initialize the plots, and now we'll refresh the devices. So this is a special Windows shell script that works on the PowerShell, and basically what it does is it will find out all the serial port devices connected to this laptop, and then it searches for a string with the name of the device to be Arduino, and then it lists down everything in this drop down menu. So we just have to click OK, and now we can just start connecting. So let's just see how this works. So as soon as I press connect, basically it's at the same 000 location. So yep, you could see the bit of a movement. Now we can test up with the angles to see if the angles are performing well. So we have it here. Now let's do the second angle. Yeah. So let's come towards these new functionalities that we have added. This will basically increment the robot in X direction and Y direction, and even there is a decrement button for X and Y. Basically this calculates the inverse kinematics and makes the end effector go forward and backward. So let's see what happens when you click over this. Now let's click over the Y increment button. Now Y decrement button. Now Z up. My bad, it's already up. Z down. It has already reached the point. Now we have the similar keyboard inputs for the same thing. We just have to click it once, and then if we press Q, it comes up. If we press W, it goes down. Now if we press Z, it goes forward X. When we press X, it comes backwards towards X. If we press C, it goes positively towards Y, that is incrementing. And then when we press V, it basically decrements. So this is like the overall functionality. Now before we start the actual plotting thing, let's just go around with the pen.m and all the other functionalities. So we have a disconnected program architecture. So we'll just run the pen.m file. Then we write a text. So this is a handwritten text. Now I just have to go over this red area to make sure it's processed. Now you can see it is. Now we just have to call the IKCon, basically the inverse kinematic solver. So what it does is it takes all the points and it basically calculates all the angles pre-hand before running it in the GUI. The benefit of this is you can basically first of all cross-check, because we have created a forward kinematics based simulator, and even all the angles are pre-calculated, so the robot works very fast as compared to on-hand calculations. So this is how it should look like. Now we'll just cross verify this using the fkind test program that we have developed. So output should look somewhat like this, and it is really close to this one. So let's just start the GUI program again. So all the angles of forward kinematic, like the inverse kinematic solver is saved in fin angles, that is finalized finished angles that we are supposed to give it to the GUI program. So we'll initialize the plot again. We'll refresh the device to find the Arduino. So it has found the Arduino at common port. We'll just connect it. So as soon as we are connected, it basically initializes the arms to go at the 0, 0, 0 position. So we'll just try to come at the center position. All right. So let's just take the Z thing down. So it is. So let's just start writing. We just click a plot hand and it should just start writing. Oh, I guess the tension is not really enough. But as you can see, it writes the complete word. Let's just retrace it back to see how it writes there. We can just retrace this back and forward to make sure that it is writing properly, and we can just try this once again to see if it's writing properly. Sorry, it's off the clipboard because the papers are short, but let's try it again. So I guess we have moved the paper, but you can see by overall movement that it writes it in the same way that we have defined it in the program. So this is our two-link robot that can write anything that is given in pen.m, and these are all it's the complete overall configuration. Thank you.